Hello everyone. Electromagnetic Waves Part 3. Electromagnetic Spectrum. In this video, I will be discussing about the electromagnetic spectrum. This figure shows the electromagnetic spectrum. Here we can see the different frequency ranges and the wavelengths. That is, the part of the electromagnetic spectrum having high frequency include the gamma rays, X-rays, and ultraviolet rays. They have got frequencies which are greater than that of visible light. Then infrared rays, microwaves, short radio waves, television and FM radio, AM radio, long radio waves have got frequencies lesser than that of the visible light. Since frequency and wavelength are related inversely, as frequency increases, the wavelength decreases. So high frequency rays like gamma rays are having lower wavelengths, while lower frequency like long radio waves have got higher wavelengths. So first we shall see about the radio waves. The radio waves consist of the long radio waves, the AM radio, the television and FM radio, and short radio waves. Now radio waves are produced by the accelerated motion of charge in conducting wires. They are used in radio and television communication systems. They are generally in the frequency range from 500 kHz to about 1000 MHz. The AM band is from 530 kHz to 1710 kHz. Now higher frequencies up to 54 MHz are used for shortwave bands. TV waves range from 54 MHz to 890 MHz. The FM or the frequency modulated radio band extends from 88 MHz to 108 MHz. The cellular phones use radio waves to transmit voice communication in the ultra high frequency band. Now the next types of waves in the spectrum is microwaves. That is, microwaves are short wavelength radio waves with frequency in the gigahertz range. They are produced by special vacuum tubes called klystrons, magnetrons, and also by using gun diodes. Due to their short wavelengths, they are suitable for radar systems used in aircraft navigation. Radar also provides the basis for the speed guns used to time fast balls, tennis serves, and automobiles. Microwaves are used in the microwave ovens, in which the frequency of the microwave is selected to match the resonant frequency of water molecules, so that energy from the wave is transferred efficiently to the kinetic energy of molecules, thereby raising the temperature of foods containing water. Now next we shall see about the infrared waves. Infrared waves are produced by hot bodies and molecules and are referred to as heat waves. They are having higher wavelength than visible light. This band lies adjacent to the low frequency or long wavelength end of the visible spectrum. That is red. That is why they are called infrared. Infrared radiation plays an important role in keeping the Earth warm through greenhouse effect. That is, when the objects on the surface of the earth gets heated, after some time they start radiating infrared rays. These infrared rays are of longer wavelength, and these infrared waves are absorbed by the greenhouse gases like carbon dioxide and water vapor, and this serves to keep the earth warm. Infrared detectors are used in Earth satellites both for military purposes and to observe growth of crops. Electronic devices, for example, semiconductor light emitting diodes, also emit infrared and are widely used in the remote switches of household electronic systems such as TV sets, video recorders, and hi-fi systems. Now we shall see about the visible rays. That is, visible rays include the part of the spectrum that is visible with our eyes. It runs from about 4 into 10 raised to 14 Hz to about 7 into 10 raised to 14 Hz, or a wavelength range of about 700 to 400 nanometer. This is the frequency range or wavelengths of the electromagnetic spectrum that is visible to the human eye. Now ultraviolet rays. It covers wavelength ranges from about 4 into 10 raised to negative 7 meter, that is 400 nanometer, down to 6 into 10 raised to negative 10 meter, or zero point 0.6 nanometer. Ultraviolet radiation is produced by special lamps and very hot bodies. The sun is an important source of ultraviolet light. Most of the ultraviolet radiation from sun is shielded by the ozone layer on Earth, protecting us from the harmful ultraviolet radiation. Exposure to UV radiation causes tanning of skin by overproduction of melanin. UV radiation is absorbed by ordinary glass. Hence, one cannot get tanned or sunburned through glass windows. Due to its shorter wavelength, UV radiations can be focused into very narrow beams for high precision applications such as LASIK. There is laser assisted in situ keratomyelitis, eye surgery. UV lamps are also used to kill germs in water purifiers. X-rays. Beyond the UV region of the electromagnetic spectrum lies the X-ray region covering wavelengths from 10 raised to minus 8 meter, that is 10 nanometer, down to 10 raised to minus 13 meter, which is 10 raised to minus 4 nanometer. X-rays are generated when a metal target is bombarded by high energy electrons. X-rays are mainly used as a diagnostic tool in medicine and as a treatment for certain forms of cancer. Since X-rays can damage or destroy living tissues and organisms, care must be taken to avoid unnecessary or overexposure to X-rays. And finally, the gamma rays. They lie in the upper frequency range of the electromagnetic spectrum and have wavelengths from 10 raised to minus 10 meter to less than 10 raised to minus 14 meter. This high frequency radiation is produced in nuclear reactions and also emitted by radioactive nuclei. They are used in medicine to destroy cancer cells. So this table summarizes the different types of waves present in the electromagnetic spectrum, that is radio, which have got a wavelength range greater than 0.1 meter. They are produced using rapid acceleration and deceleration of electrons in areas. Detection, receivers areas. Microwave, that is from 0.1 meter to 1 millimeter. They are produced using klystron valve or magnetron valve, and they are detected using point contact diodes. Infrared, 1 millimeter to 700 nanometer. They are produced by the vibration of atoms and molecules. They can be detected using thermopiles, bolometer, infrared photographic film, etc. Light, that is from 700 nanometer to 400 nanometer. Electrons in atoms emit light when they move from one energy level to a lower energy level. The eye, photocells, photographic films, etc. Then ultraviolet, that is from 400 nanometer to 1 nanometer. Inner shell electrons in atoms moving from one energy level to a lower level. Photocells, photographic films. Then X-rays, that is 1 nanometer to 10 raised to minus 3 nanometer. X-ray tubes or inner shell electrons. They can also be detected by using photographic film, Geiger tubes ionization chamber. Similarly, gamma rays, which have got a wave range of lesser than 10 raised to minus 3 nanometer, and they are produced by the radioactive decay of the nucleus. So this is the end of this video. In this video, if you have got any doubt, please do comment in the section below. Thank you.